Hello everyone. This week is the National Science Week for 2020 in Australia. I would like to take this opportunity to talk about something that might be of interest to the audience. So let me start about the communication. Communication is very important, and there are three particularly languages that we should be able to master, in the sense that we need to communicate. In the communication between people, then we need, of course, our language. So that's English. But there are two other languages that I would like to emphasize. The second one is the language of coding. So this is the language that we use to communicate with machine, to instruct machine to carry out the computation that we want. But most important, if we want to talk to nature, to understand nature, then we need the language of mathematics. And in the language of mathematics, the most beautiful sign is the equal sign. So the equal sign is the most beautiful one. And we have two things, like A and B. And we label them A and B because they are distinct, of course. The equal sign is a sign, particularly mathematics, that bring the two together. The same turn out to be the same in all aspect. If we can put A equal B, that is one of the most beautiful signs in mathematics. And I take example, if we have one apple in my pocket and I put another one in, I have another apple, and that is the same as two apples that have been there before. So that's something very simple. But this simple equation took the whole book of few thousand pages to verify and to justify this. Today I would like to talk about another beautiful equation, the equal sign, and A and B. So if you take on the one side of the equation, E, which is the energy, like the kinetic energy of a traveling bullet, of the potential energy if I hold a ball here, so it has a potential to create energy when I release it from certain height. And this is the famous equation that everyone should know. E equal m, which is a mass of an object, and C square, where C is the velocity of light in vacuum. So this is an amazing equation, introduced and verified and proved by Einstein. And this just say that energy is now nothing more than the mass in the units of velocity of light. So this is very, very celebrated equation. And in talking about this equation, people usually talk about nuclear energy. So I would like to take this to explain this equation. So before that, you will take a chunk of wood, as I have done in my home, particularly this winter, and we burn it. And what left over is the ash. And if you capture all the gas released from the burning, and the rest is the heat that it's been released from burning a pile of wood. So this energy here is actually the difference between the mass of the wood subtract of all what left over. And of course we times C square. But actually the what left over, namely ash and gas, is not very much different from the mass of the initial chunk of wood that we burnt. So this energy is okay, keep us warm, but not very much. And then if we talk not very much as in the nuclear chain reaction. So I talk about fission, is there are many nucleus, radioactive nuclear materials. So, but I just take example of the 235 uranium. And if we shoot a neutron into this one, and that nuclear is now going to another isotope, don't worry about the technical terms. Essentially, uranium we excited with certain neutron, and that will then disintegrate into the so-called krypton, as in Superman kryptonite, barium, and release 3 neutron, and then the energy in terms of the gamma rays. The 3 neutron here then could then, if we have a lump of nuclear fissile nuclear material, then these 3 N will then excite another nuclear in the surrounding, and that will create further neutron and further energy, and that we call the chain reaction. But the beautiful thing about this one in relation to this equation is if we take the energy, the mass difference here, subtract the mass difference that we have, then that is the energy released. Of course, we have to time the c square, which is the velocity of light in vacuum, square it up. And this releases much more energy than burning wood. And further still, we have another type of nuclear reaction, it's called fusion. And in terms of fusion, we can take a deuterium, which is an isotope of hydrogen, and we somehow let it interact with the tritium, another isotope of hydrogen. Then we would have a so-called helium, and of course there's 1 neutron left. 2 neutron plus 3 neutron, 4 plus 1, so equal 5. But once again, the difference with the mass here, subtract this mass, and this mass will give us the energy release. And it released million times more than energy would have been released by burning wood. And that is the basis of the nuclear power or nuclear bomb. If the power is released in a short interval of time, that will become an explosion. But the point I want to raise here is all of these actually satisfied this equation. Energy equal to the mass times c squared. So that's very good. That is celebrated and actually a fundamental and help us to advance the science and advance the understanding of the universe. But in all these 3 examples, burning wood, or using fission, nuclear, or using fusion, what we have seen is there's some remainder. After we burn them or we have the reaction, in terms of this particular fission reaction, then we still have krypton and barium left and the neutrons left. In terms of fusion, which is the reaction that are happening on the sun for billions of years, and that gives us all the energy we have. In fact, all the life on Earth actually survive or feed on the energy from the sun. Without the energy from the sun, there will be no life on Earth. And you see that there's always a difference. But is there a way to turn totally? So the energy is just the difference before and after in the mass times c squared. But is there a way to turn everything into energy without any remaining leftover or byproducts? Yes, there is, and that is in the form of the so-called antimatter. So if we have a matter, like electron is a matter, it's a form of matter, actually it's a fundamental particle creating matter in this universe. And we call it E minus because it carries a negative charge. And by a genius invention of a man called Paul Dirac. He proved that every matter has a counterpart called antimatter. So we have, for the antimatter electrons, what we call it positron. It's the same electron in all aspects except one, namely the charge. So that's why I have the plus here. So it carries a positive electrical charge. And if the matter encounter antimatter, then they will destroy totally and give us energy. So there's no matter left, there's no mass left. Unlike burning wood, unlike nuclear reaction, when matter meets the opposite, the yin meet the yang, then they will totally annihilating each other, and then there will only the energy left over. And this is the most efficient conversion of mass of this one plus the mass of positron into total energy. And that is, once again, satisfying the famous and celebrated equation E equal mc squared. So in the next episode, I will talk a little bit about matter and antimatter. Thank you for listening.